This time, we will provide training on the WebUI system. This training will be conducted in the order of System, Update, and Service. In the System section, components of NAC, such as the policy server and network sensors, are managed based on device. It allows you to view device-based information and remove unused components. Here are tasks that can be performed in System. You can configure and modify settings based on the device. This includes performing image upgrades and managing system operation-related settings. I will proceed with the Assign System Tag task. After selecting the target device, choose Assign System Tag from the task options. Select the appropriate tag from the tag list that matches the purpose and proceed with the configuration. You can verify the progress and status as shown on the screen. I will proceed with the Change CLI Password task. After selecting the target device, choose Change CLI Password from the task options. Enter the new password, and after confirming the completion message, log in using the updated password. I will proceed with the Change CLI Privileged EXEC Mode Password task. After selecting the target device, choose CLI Enable Password Change from the task options. Enter the new password, and after confirming the completion message, log in using the updated password. I will proceed with the Delete System task. After selecting the target device, choose Delete System from the task options. You can verify the progress and status as shown on the screen. I will proceed with the Edit Device Settings task. After selecting the target devices, choose Edit Device Settings from the task options. Select the appropriate environment settings for the purpose, set the conditions, and click the Execute button. You can verify the progress and status as shown on the screen. I will proceed with the View Appliance Settings task. After selecting the target device, choose View Appliance Settings from the task options. You can verify the progress and results as shown on the screen. I will proceed with the Update Latest System Images task. After selecting the target device, choose Update Latest System Images from the task options. Once the screen refreshes, you can verify the progress and status as shown on the screen. I will proceed with the Update Specific System Images task. After selecting the target device, choose Update Specific System Images from the task options. Select the upgrade image from the list and proceed with the upgrade. Once the screen refreshes, you can verify the progress and status as shown on the screen. I will proceed with the Restart task. After selecting the target device, choose Restart from the task options. You can monitor the restart status by sending a ping to the device's IP address, as shown on the screen. Once the restart is complete, refresh the screen to verify the progress and status as displayed. I will proceed with the shutdown task. After selecting the target device, choose Shutdown from the task options. Once the task is completed, you can verify the shutdown status of key systems and processes by using the Show Process command in CLI mode, as shown on the screen. I will proceed with the syscollect task. After selecting the target device, choose syscollect from the task options. In addition to the default system information collected, select additional collection items as needed and click the Start button. You can monitor the progress in the top right corner of the system screen. Once the log collection is complete, click the completion message to verify the results, as shown on the screen. In the Sensor section, you can apply or modify the settings for virtually registered network sensors. Here are the tasks available in Sensor. You can review the settings for network sensors or perform batch modifications. Let's learn how to add a sensor. Select Create from the task options. Follow the on-screen guide to perform the task according to your objective. I will proceed with the View Appliance Settings task. After selecting the target sensor, choose View Appliance Settings from the task options. You can verify the progress and status as shown on the screen. I will proceed with the Edit Appliance Settings task. After selecting the target sensors, choose Edit Appliance Settings from the task options. Select the appropriate settings for your purpose, configure the conditions, and click the Save button. You can verify the progress and status as shown on the screen. I will proceed with the Edit All Sensors Operation Modes task. After selecting the target sensors, choose Edit All Sensors Operation Modes from the task options. Select the desired operation mode for the sensors and click the Run button. You can verify the progress and status as shown on the screen. I will proceed with the subnet node scan using the Perform Action for Sensor feature. As shown on the screen, there are currently no nodes registered to the network sensor. To perform this task, navigate to the system's Sensor Management menu. After selecting the target sensor, choose Perform Action for Sensor from the task options. Select Scanning Subnet Nodes and click the Run button. You can verify the progress and results in the node management screen for the target network sensor, as shown on the screen. In the Appliance Settings section, you can define the default settings applied when a network sensor is initially registered in the NAC. The initial default values include the following items: security, proxy service for OS update, SNMP agent, asset alerts, date and time, miscellaneous. To modify settings different from the initial defaults, go to System, select the device, and individually update the settings in the Appliance tab. The Security section restricts the number of IP addresses that can access the network sensor CLI console to a maximum of 2. For security compliance, more than 2 IP addresses cannot be configured. The Proxy Service for OS Update section configures the network sensor to function as a deployment server. This setting is available on devices with a hard disk capacity of 50 GB or more. It synchronizes files distributed by the NAC and facilitates their deployment within the local network. The SNMP agent section is configured when collecting system information from NAC devices using SNMP from an external source. The supported SNMP version is 3, which provides 3 authentication methods. This feature is typically used to monitor system resources and operational status through an NMS. The Asset Alerts section is configured to notify the administrator when the usage of disk, CPU, memory, or nodes in the NAC system exceeds a specified threshold. By setting thresholds, the system can send warning notifications to the administrator when resource usage surpasses the defined limits, enabling proactive management to prevent system malfunctions. The Date and Time section allows you to configure the system's time zone. Time zones are categorized by continent and city. You can first select from 9 continents and then specify a city within the selected continent. By default, the time zone is set to Asia Seoul. The Miscellaneous Settings section allows you to configure the default character set for network packets, as well as settings for network sensor debugging and node status checks. The default character set specifies the encoding for strings in network packets. It supports configurations for Korean, English, Japanese, Chinese, and multilingual settings based on Unicode. The sensor debug log was previously performed using commands in the network sensor CLI mode. However, with the updated functionality, debug settings can now be configured through the management console. When generating debug logs, you can specify the storage location. Options include no selection, local, policy server, local and policy server. The node status check allows you to configure a minimum interval for checking the up-down status of nodes. If the network sensor has a disk, it operates according to the specified settings. However, if the network sensor does not have a disk and no selection or local is chosen, debug logs will be stored on the policy server. The Node Status Check section allows you to configure Node Health Check Method, Status Scans Period. The Node Health Check Method, min period, is a setting for configuring the transmission interval of ARP packets used to check node statuses. ARP packets are sent at the specified interval to monitor the status of nodes. The Whether to Check Node Status setting defines the number of ARP packets that the network sensor can send per second. If the number of packets sent based on the minimum node status check interval exceeds the configured value, ARP packets will be sent according to the maximum requests per second setting. In the node status check process, the first criterion for determining a node's status as up is as follows. If an ARP packet is generated by the endpoint device and received by the network sensor within the initial 120 seconds, the network sensor will maintain the node's status as up. In the node status check process, The second criterion for determining a node's status as up is as follows. If no ARP packet is received from the device to the network sensor within the first 120 seconds, the network sensor sends ARP requests according to the status scans period option. If a response to the network sensor's ARP request is received within 180 seconds, the network sensor maintains the node's status as up. In the node status check process, the criterion for determining a node's status as down is as follows. If no ARP packet is received from the device to the network sensor within the first 120 seconds, the network sensor sends ARP requests according to the status scans period option. If no response to the network sensor's ARP request is received within 180 seconds, the network sensor changes the node status to down. In the Management Console, you can select the system and navigate to the Network Appliance menu under the System Default menu. In the Network Sensor section, you can configure the default operational settings applied when a network sensor is first registered in the NAC system. The initial default values include the following items: sensor operation, traffic monitoring, node registration, node information scan, network scan, node status scan, subnet node scan, DHCP, virtual IP, IPAM, miscellaneous. To modify settings that differ from the initial defaults, navigate to System, select the device, and individually update the interface settings under the Sensor Settings tab. The Sensor Mode section is used to configure the mode in which the sensor operates. The available sensor modes are Inactive, Host, and Mirror. Inactive mode. When set to inactive, the network sensor does not perform any collection or control functions, regardless of the operational mode settings. Host mode. When set to host, the network sensor operates as a single host on the network. The collection and control functions will work according to the operational mode settings. Mirror mode. When set to mirror, the network sensor collects and controls traffic through its interfaces based on the operational mode settings. As explained earlier, for the network sensor to perform actual network information collection and control, the sensor's operating mode must be set to enforcement. The operational modes of the network sensor include monitoring and enforcement, and its behavior is defined by combining these operational modes with the operation mode. Inactive mode. In the inactive operation mode, this takes precedence regardless of the operational mode combination. Both monitoring and enforcement modes result in no functionality for the network sensor. Host mode. In host operation mode, when combined with the monitoring operational mode, the network sensor performs network information collection, e.g., node information scan, network scan, node status check, subnet node scan, but does not perform network control. When combined with the enforcement operational mode, the network sensor performs both network information collection and network control. Mirror mode. In mirror operation mode, when combined with the monitoring operational mode, the network sensor does not function. When combined with the enforcement operational mode, the network sensor performs IP-based network control. A typical network sensor setup uses host operation mode with enforcement operational mode. The unmanaged IP control section allows the network sensor to detect packets originating from nodes using non-managed source IPs and take control actions in the unmanaged IP range. This feature operates only in host mode enforcement mode. The traffic monitoring section configures the analysis of packets received through the mirroring port, displaying traffic metrics or providing destination-specific traffic information. The traffic monitoring feature operates only in mirror operation mode, combined with enforcement operational mode, and when the mirror scope is set to local. The maximum registration for a MAC section specifies the maximum number of nodes with the same MAC address that can be registered in the NAC. When configuring the maximum registration count, it must be set higher than the number of ranges managed by the network sensor to ensure that devices using the same MAC address, such as a gateway, can be registered properly. The Unused IP Registration section allows you to decide whether to automatically register currently unused IPs as nodes in the network managed by the network sensor. Registering unused IPs has the advantage of enabling IP management policies to be used in a reserved format. However, registering unused IPs may impact product performance as the number of managed nodes increases. The IP Utilization Alert section logs an alert when the utilization of IP addresses in the network managed by the network sensor exceeds the configured threshold. Although the automatic deletion feature helps ensure smooth usage of IP resources, if IP resources are consumed faster than they can be automatically cleared, this feature notifies the administrator with a warning to manually clear and manage the resources. The Node Information Scan section configures the collection of network information to inspect the details of nodes detected by the network sensor. Configurable options include Port Service Scan, SNMP Information Scan, WMI Information Scan, NetBIOS Name Queries. When the scan interval is set to 0, only newly registered nodes and nodes manually scanned by the administrator will be scanned, with no periodic inspections performed. The default interval is set to 12 hours, and it can be configured to a minimum of 1 minute or a maximum of 1 year. The Network Scan section configures the settings for scan-specific items using the network sensor. You can enable or disable scanning for the following items: DHCP server, UPnP, HPSLP, SIP. The DHCP server scan section sends DHCP request packets during a network scan and detects DHCP servers by checking the DHCP reply packets received in response. The UPnP scan section uses the network scanner Nmap to collect and detect information. The HPSLP scan section detects services by checking for responses to multicast requests sent to UDP port 427 at the multicast address 224-00160. The SIP scan section detects devices by sending SIP options to UDP port 5060 and analyzing the platform information included in the user agent header. The Node Status Scan section allows you to configure the inspection of MAC IP clone detection. The MAC IP clone detection section configures the detection of MAC IP cloned nodes within the network managed by the network sensor. During the node status check, the system verifies whether more than 5 responses are received within a 0.5-second interval through ARP requests. The Subnet Node Scan section allows the network sensor to periodically scan the managed network range and detect changes. The default execution interval is set to 6 hours, and it can be configured to a minimum of 10 minutes and a maximum of 1 year. The scans per second setting defines the number of nodes the network sensor can scan per second during a subnet node scan. If set to 0, scanning is not performed. The default value is 5 scans per second, with a maximum of 100 scans per second. This is a configurable item when using DHCP in the network sensor. I will explain the special parts related to the NAC DHCP server among the settings. The service target item allows you to select one of local, remote, or local and remote to designate the server that can assign DHCP IPs. The sensor IP pool item configures the address range to be used for sensor DHCP IP allocation by network sensor. The IP assignment prevention target item designates targets that the DHCP server does not assign IPs to, which can be set to nodes violating the No IP Changes policy or nodes without a No IP Changes policy. The static DHCP item applies the IP change prevention and collision protection policies to nodes assigned DHCP IPs by NAC, providing fixed IPs. Let me briefly explain the service target settings related to DHCP configuration. When set to local, the DHCP server is designated only on the network sensor. When set to remote, the DHCP server is designated only on the policy server. When set to local and remote, the DHCP server is designated on both the network sensor and the policy server. If the remote option is selected as the DHCP target, the switch must be configured with the DHCP helper address IP set to the policy server's IP. This ensures that DHCP Discover packets are properly forwarded to the policy server, enabling normal DHCP service functionality. The virtual honeypot IP section allows you to configure the number of honeypots used by the network sensor for anomaly detection. Honeypot IPs are automatically assigned within the managed range of the network sensor and are registered with the network sensor's MAC. If a device sets the honeypot IP, it will automatically be renewed. If there are fewer IP resources than the configured number, only the available number of IPs will be set. The IPAM section allows you to specify initial policies for newly registered nodes or configure the IP conflict prevention feature for the sensor's IP. For newly registered IP MAC addresses, you can set policies such as deny modes, deny MAC, deny IP, or deny IP MAC. Allow and special policies. Allow mode. Enable change prevention. Enable conflict prevention mode. The sensor IP conflict prevention feature is enabled by default on. If set to off, the IP assigned to the network sensor will not be protected, potentially causing service issues. The miscellaneous settings section allows you to specify exception targets when the network sensor performs blocking actions. The configurable exception targets include Bridge MAC, Bridge IP, Exception MAC. In the Management Console, select System, then navigate to the Network Sensor menu under the System Defaults submenu. The Sessions section allows you to view and delete sessions that are connected to the WebUI with administrator privileges. When a session is deleted, the connected session will be terminated immediately, regardless of the timeout duration. Let's proceed with the session deletion task on the session screen. In the Management Console, select System and navigate to the Session menu. Select the target session to delete. Choose Delete from the Task Selection menu. You can confirm the task's completion on the screen, as shown. The License section allows you to register a license file containing 22 configuration items related to the NAC product. The license file includes settings such as module operation permissions, validity date, maintenance, and the number of devices for the NAC product. In the Management Console, select System and navigate to the License menu. Click the Register License button. Select the saved license file using the Select File button and proceed with the upload. Once completed, the license registration will be finalized, as shown on the screen. The license violations include exceeding the licensed device count and maintenance period expiration. For exceeding the licensed device count, detailed node information will not be displayed. For maintenance period expiration, Genie and data updates will not be performed, and technical support will be restricted. In the event of a license violation due to exceeding the licensed device count, a license warning message will appear on the Management Console screen, as shown. Please check the license device count in the System License menu. In the event of a license violation due to the expiration of the maintenance period, a warning message will appear on the screen, as shown. Please check the maintenance expiration date in the System Geneon Data menu. The Update section allows you to manually upload and manage software for the NAC system. The software items that can be uploaded include Policy Server and Network Sensor OS image files, Agent Package files, Linux, Windows, Mac OS, Mobile Monitoring Installation files, Android, iOS. To manually upload an image, click on the Geneon Software menu in the System. Next, click on Upload File, select the task, and upload the image corresponding to your purpose. Once the upload is complete, you can check the details through the list. The Plugin section is divided into two menus, Agent Plugin and Policy Server Plugin. You can manually upload single plugin items in this section. In the Agent Plugins section, you can manually upload single plugins rather than the entire set of Agent plugins. The full set of Agent-related plugins is included in the Agent Package file, which is registered when uploaded through the Software menu. In the Policy Server Plugin section, you can manually upload web plugins that can be used on the Policy Server. By default, no plugins are provided for the Policy Server. Custom plugins are provided based on site-specific requests. To manually upload an Agent plugin, click on the Agent Plugin menu under the System. Next, select Upload File from the Task Selection menu. Choose the appropriate plugin for your purpose and proceed with the upload. The Geneon Data section allows you to check update items provided by NAC or manually perform update commands. The Geneon Data update items available include CVE update information, PI update information, node information, platform information, OS update information. Additionally, the maintenance expiration date is displayed. If maintenance expires, SMS notifications and operational data updates will be restricted. The Service Control section allows you to perform controls related to the operation of the NAC system. Apply Policy immediately applies all configured policies to network sensors and agents. Stop Service stops all services currently running on network sensors and agents. Restart Web Application provides the ability to selectively restart the following web applications offered by the Policy Server: Management Console, CWP, IP Request System. The Connection Port section allows you to view all network ports currently in use by the NAC system. If normal communication is not functioning, check the connection port information and request permission from the Perimeter Security Solutions as needed. The Debug Log section provides the ability to view debug logs in real time or download them for analysis purposes. Available debug logs include Elasticsearch, HTTPD, MySQLD, sysinspect, System, Tomcat. The syscollect log allows you to view a consolidated file of all debug logs when generated through a CLI command. To view debug logs via the WebUI, click on the Debug Logs menu in the system. You can check the desired debug logs. In the System menu, you can perform batch configuration and deletion of network sensors through System menu. Additionally, you can configure profiles for newly added network sensors and register licenses through the system defaults. The Update menu allows version management for the policy server, network sensors, agents, and agent plugins. The Service menu provides system control and access to debug information. This time, we learned about the WebUI system. Next time, we will teach about the 5th chapter, Geneon NAC agent.